In this lesson, we're going to be looking at what we call the distance formula and the midpoint formula. And we're going to be looking first of all at how we develop those formulas and then how we use them. When we're looking at a distance, then we're talking about a distance between 2 points. Now, on a horizontal line, we know how to find distance. If we're going from 2 to 6, well, we know we've gone a distance of 4 units. And one of the easiest ways to get that is just to subtract 6 minus 2. Now, for distance, we're not concerned with which direction. Later on, when you get into vectors, you'll be talking about directed distances where the direction is important. But in this case, we're just talking about the distance between 2 points. And it would be the same as the distance between 2 places, between 2 cities. It doesn't matter if you're going from New York City to Los Angeles or Los Angeles to New York City, the distance between them is the same. So most of the time, then what we will do is we will put that distance inside absolute value bars to show that it doesn't matter which way we're going. The distance between 6 and 2, no matter if you're going from 6 to 2 or 2 to 6, is 4 units. And so we know how to find distance on a horizontal line. We know how to find distance on a vertical line. It would be the same thing. If we're going from 3 to 7, then we've gone a distance of 4. The problem comes when we want to find the distance on a line that's not vertical or horizontal. So if we were looking at that, and let's say that we have a line, and I'm not going to put it at coordinates. We're not concerned necessarily here with the coordinates. What we're wanting to know is how to find the distance on this line, and we'll call that D. Now, we do know how to find distances for vertical and horizontal. So in geometry, you learn that you can construct lines. And so we're going to construct a line here. And then we're going to construct its perpendicular from this point. We constructed these parallel to our x and our y axis, and they're perpendicular to each other, so we formed a right triangle. Now, let's call the coordinates of this point x sub 1 and y sub 1. And the coordinates of this point are x sub 2, y sub 2. Okay, we have a third point here, and for this point, its x value is the same as that point. So the coordinate for this point would be x sub 2. The y value for this point is the same as the y value for this point, which would be y sub 1. Now, we can find the distance of this horizontal line. It's going to be the x's that changed, so I'm going to put it in absolute value, and x sub 1 minus x sub 2, and it doesn't really matter which one's your x sub 1, which one's your x sub 2. It's just the difference in the x's, and we put it in absolute value to show that we're going to get a positive answer no matter which one we do. Now for over here, it's the y values that changed. So this distance would be y sub 1 minus y sub 2. Again, we'll use the absolute value of it. So now we have us a right triangle. We have the length of one side and the length of the other leg. And so using the Pythagorean theorem, we know that d squared, or let's put it this way, we know that the sum of the squares of the two sides whoops, that's a minus. Is equal to d squared. Or if we want to find d, we can take the square roots of both sides. So we're going to write our distance formula as the square root of the change in the x's. Now, if you notice, I just changed my absolute value bars to parentheses. The only reason I can do that is because we put the absolute value bars to show we wanted a positive number there. But we know no matter what kind of number we have, if we square it, our answer is going to be positive. And so it's not necessary then to put our absolute value bars. We can just put our grouping symbols of our parentheses. And y sub 1 minus y sub 2 squared. And this is how we will find the distance between any 2 points. So let's look at some points and find the distance between them. Let's say that we have the points negative 3, 2, and 5, 8. We want to find the distance between them. So the distance is equal to the square root of the change in the x's. It doesn't matter which one we put first. So negative 3 minus 5 squared plus the change in the y's, 2 minus 8 squared. So that's going to give us negative 8 squared plus negative 6 squared. Now, if you're using your calculator here, it's very important that you put that negative 8 inside parentheses so that when it squares it, it will make it a positive 64 plus 36, which is 100, and the square root of 100 is 10. So that would be the distance between those 2 points, would be 10 units. Let's look at another one. If we have the points negative 4, negative 1, and 2, negative 3, then our distance is going to be the square root of the change in the x's squared plus the change in the y's squared. So that was minus a negative 3. Okay, this gives us negative 6 squared. Now minus the negative's a plus, so that would end up being 2 squared. So we have 36 plus 4 is 40. And the square root of 40, we can simplify that because that's the same as the square root of 4 times 10, which would be 2 square roots of 10. Now, if you're actually talking about a distance, then it might be important for you to go ahead and get an approximation on that, because we know if we were actually measuring something, our rulers don't have 2 square roots of 10. So you might need to go ahead and put that into your calculator and get an approximation. So that's approximately 6.32, depends on what you want to round off to. If we round off to the nearest hundredth, then 6.32. So you may have to, for circumstances, get an approximation. Okay, let's look at one more, because you can have all different types of numbers, and sometimes when you first look at them, they're a little scary. But let's say that our points were 2 square roots of 3 and square root of 6 and negative square root of 3, 5 square roots of 6. It doesn't matter what your numbers are. You'd put them into the formula. So our distance is equal to the change in the x's squared plus the change in the y's squared, which will give us minus the negatives the same as the plus. So this is 3 square roots of 3 squared. And this would be negative 4 square roots of 6 squared. Now when we square a product, we square each factor. So 3 squared is 9. Square root of 3 squared is 3. Negative 4 squared is 16. Square root of 6 squared is 6. So we have 27 plus 96, which is 123. And we can't simplify that. It is divisible, and you might want to check 123 is divisible by 3. But it goes in there 41 times, and 41 is prime. So it has two factors that are prime, and therefore we can't reduce it any. All right, this is finding the distance between 2 points. Now another thing that we want to be able to do is to find the midpoint. And if we have a line and we want to find the middle of it. Now, if our line, let's just take one. Okay, if we're talking about our line and we want to find the middle of it, well, let's say that this coordinate is 4 and this coordinate is 10. And we want to find the middle. We want to find the midpoint. Well, you could find the distance between them, which is 6, then take half of 6, which is 3, and then add that to your beginning point. And that would get you to 7. And that's one way of doing it. But another thing to remember is anytime you're wanting to go toward the middle, well, that's the same as averaging. So if we took 4 plus 10, and we divided it by 2 because there's 2 points, then we're going to have 14 divided by 2 is 7. And so when we want the middle, then we average. And so we can find our middle there. Now, let's go back then because we're wanting a point and define the middle of a line. Let's just go back and look at a line again. And we're not going to be actually measuring these, so we may not hit something exactly, but okay, if we have a line and we want to find the midpoint of that line, well, we only know how to average when we're dealing with vertical and horizontal. So let's construct our vertical and horizontal lines again. And I did put this one on a place where we could actually see what our points might be and what ends up happening here. Okay, we're going to call that close enough. Now, if we label our points, and we call this one x sub 1 and y sub 1, and this point is x sub 2 and y sub 2. Now, we want to find the midpoint of that line. Well, we know how to find the middle of horizontal and vertical. So we could actually find the middle of this line. This coordinate, the x is the same, so this would be x sub 2, and its y value is the same as this point, so that would be y sub 1. Now, we can find the middle of this one by averaging our x's. It's going to be x sub 1 plus plus x sub 2 divided by 2. Now, if we look at the distance of this line, it's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units. So we happen to know we can actually look at this. This is going to be 2, 3, 4, 5, 6, 7. This is going to be the middle of that line. If we look at this one, we're going to be averaging the y's, which would be y sub 1 plus y sub 2 divided by 2. And let's just check this line out. It's 2, 4, 6, 8. So the middle was 4. And so right here's the middle of this line. Now, in geometry, one of the things that you learned was if you construct the perpendicular bisector in a right triangle, if you construct the perpendicular bisectors of the lines, of the legs, they also bisect the hypotenuse. So when we found this x value for the middle of this line, then that's the same as the x value for the middle of the hypotenuse. When we found the y value for this line, that was the same as the y value for the hypotenuse. And so therefore we can have what we call our midpoint formula, which is x sub 1 plus x sub 2 divided by 2 will be our x value, and y sub 1 plus y sub 2 divided by 2 will be our y value. And this is what we call our midpoint. So let's look at some problems and how we would go about using our midpoint. Let's say that we have the points 3, 9, and 5, 12. And we want the midpoint of this. Well, it's going to be the average of our x's, so 3 plus 5 divided by 2, and 9 plus 12 divided by 2, which would give us 8 divided by 2, and this would be 21 divided by 2. So our midpoint ends up being 4 21/2. And normally we'll leave it 21/2. We won't change it to a mixed number or to a decimal. So that would be our midpoint. Now, it doesn't matter what our points are. We go through and we do the same process. If we have the point 7 square root of 3, negative 6, and 3 square roots of 3, negative 2. Well, then our midpoint is going to be the average of our x's and the average of our y's. So that would be 10 square roots of 3 divided by 2. This would be negative 8 square roots of 2. And we can divide our coefficients. So this is 5 square roots of 3, negative 4. And that would be our midpoint. If we had as our point negative 2/5, 7/15, and negative 2/5, negative 4/15. Well, the formula is the average of our x's and the average of our y's. So this would be negative 4/5 divided by 2. And this would be 3/15, which we'll reduce in just a second, divided by 2. Now, to divide by a fraction, you multiply by the reciprocal of your divisor. Well, our divisor is 2, so the reciprocal is 1/2. And we can reduce, and we'll end up with negative 2/5. Okay, we said that would be 1/5, because we can reduce 3/15. Divided by 2 is the same as times 1/2, and that would be 1/10. So we have our midpoint. What we want to look at now is a circle, and because it uses both the distance formula and it also uses the midpoint formula as we're looking at it. Now, by definition, a circle is not just a round thing, as we often hear people say. But it's the set of all points in a plane that are equidistant from a fixed point called the center. And the fixed distance from the circle's center to any point on the circle is called the radius. So what we have then is we have a circle and we have a fixed point that we call the center. Now I'm going to take this point and I'm going to label it HK. And then we have in a point somewhere on the edge of the circle, XY. So sometimes you'll also hear this defined as it's a set of all points XY that are equidistant from the center. Now that distance from the center to the edge of the circle is called the radius. And so we have then our radius. And we have our points XY. Okay, so that's our definition. Now, if we look at what we just learned about distance, then we know that the distance was equal to the square root or the distance squared. So if we're going to talk about our distance here, which is the radius, it's the change in the x's, which would be x minus h squared, plus the change in the y's, that would be y minus k squared, equals the radius squared. What I did was I took my distance formula and I squared both sides, which got rid of the radical. This is our form for a circle. This is our equation for a circle, and it's a circle where the center is at HK and R is the radius. And so we have our center HK, and then R equals the radius. So some of the things that you're going to need to be able to do is, given the center and a radius, you should be able to write the equation. If you're told that you have a circle and the center is at 5, -1, and you have a radius of 3. Well, this is your h, this is your k, so it's simply a matter of plugging it into the formula, which would be x minus h squared plus y minus k, which is -1 squared, equals the radius squared. And if we went and simplified that, we have x minus 5 squared plus y plus 1 squared equals 9. And that's the equation for a circle whose center's at 5, -1 and has a radius of 3. Now if we wanted to graph that, okay, our center was at 5, -1, so we have 5, -1. We have a radius of 3, which means from that center in all directions, we're going to go out 3 units. Connecting them then, we have the graph of our circle. So we could go through and then actually graph our circles. Okay, let's look at another one. Let's say that we have a center. We have a circle, and the center's at 4, 0. And we have a radius of square root of 6. Okay, our equation is going to be x minus h, which is our x value, squared, plus y minus k squared equals our radius squared. So this will be x minus 4 squared plus y squared equals 6. We have our equation for our circle. So if you're given a point and you're given the radius, you should be able to write the equation. If you're given the equation in our graphing form, then you should be able to give the center and the radius. Let's say that you were told you have a circle that's x squared plus y squared equals 9. Well, in this case, we're not subtracting anything from the x. So in that case, our center for our x value is 0. Our center for our y value is 0. Our radius will be the square root of 9, which is 3. So that would be the center of our circle and our radius. If we had as our equation x minus 2 squared plus y plus 4 squared equaled 16. Okay, our center, now this is in the form of x minus h. So h is going to be 2. Now another way of finding it is like what we did when we were doing our transformations. If we'll set that equal to 0 and solve, then x equals 2. And it's still doing the same as the transformations that we did. Our general form, our parent function, would be the x squared plus y squared equals whatever. Well, in this case, this is saying that we're going to go 2 units from that, which was at 0, and we'll go 2 units to the right. So x is 2, and y is going to be negative 4. So our center will be the point 2, negative 4. Our radius is the square root of 16, so it would be 4. Again, if we wanted to graph that, our center was at 2, negative 4. We have a radius of 4, so we're going to go 4 in all directions. And then we could draw our circle. So if we draw our circle through those points, this is a great circle, then that would be pretty close. And we would have our circle drawn. There are times, though, that we have the equations for our circle and they're not in our graphing form. And so we're going to need to put them in graphing form. To do that, we're going to do completing the square. Let's say that we had as our equation x squared plus y squared plus 8x plus 4y plus 16 equals 0. Now the big key to knowing when you're going to have to do completing the square, when you're simplifying, is when you have this linear term. You have an x or a y square and you have a linear term. Then you have to do completing the square. So the first thing I'm going to do is rearrange this, putting my x's together. So x squared plus 8x. I'm going to leave a space. Then I'm going to put my y's. So I have y squared plus 4y. And then I'm going to move my constant to the other side by doing the inverse operation, which would be subtracting 16. Now I want to figure out what I need to add to this side to make a perfect square. And if you remember, what we did was we took half the linear term and squared it. Well, half of 8 is 4, squared is 16. If you add 16 to one side of the equation, you have to add 16 to the other. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 to this to make it a perfect square. and I'll add 4 to the other side. Now I can write these as a perfect square because I just made it one. It's going to be x plus 4, what I squared, plus y plus 2 squared. This is the sign that determines what sign you'll put here. And then whatever you squared to get the 4 is what number we'll put here. And over here we get 4. So now we have a circle whose center's at -4, -2, and it has a radius of the square root of 4, or 2. Okay. We'll do another one. X squared plus y squared minus 6y minus 7 equals 0. Okay, we're going to have to do some rearranging. Now, there was no linear term of x, but we have y squared minus 6y, and the constant will move to the other side by adding 7 to both sides. Now, we don't have to do anything to the x squared because there's no linear term for the x, but there is for the y, so we're going to have to do our completing the square. Well, we'll take half of 6, which is 3, and square it is 9. So we'll write this as x squared plus, this would be y minus 3 squared equals 16. Well, when we go to identify our center, this one we're not transforming anywhere. We're not shifting, therefore it stays at the 0. So we have 0, 3. Again, you do that. When you're dealing with things inside the parentheses, you undo. So we would add 3. And then our radius is 4. There are times that we may get into some things that look different, but we still do the same process. So x squared plus y squared plus 3x plus 5y plus 9/4 equals 0. Well, let's do some rearranging. We have x squared plus 3x plus y squared plus 5y. Now, this 9/4 I need to move to the other side, so I'll do the opposite. I'll subtract it. So 9/4. Okay, to figure out what to add, I take half the middle term, so that would be 3 divided by 2, and I square it. Well, when you square a fraction, you square the numerator, you square the denominator. So we're going to add 9/4 to both sides. Here I would take half of 5 and square it. So that would be 25/4. And I'll add that to the other side. Can write this as x plus 3/2 squared plus y plus 5/2 squared equals 25/4. So our center will be at -3/2, -5/2, and our radius would be 5/2. If we wanted to graph that, well, our center's at -3/2, -5/2, which would be each one of these, that would be 2.5. So that's the same as 1.5, 2.5. Now our radius is 5/2. So you could think of each one of these as 2/2, so that'd be 1/2, 3/2, 5/2, or it's 2.5. So there's 1, 2.5. Okay, the half, 3, 5. And so we would do that for all of our points. And then we would simply draw our circle around those points. So this is how we go about finding the equations for circles and graphing them and finding the centers. So you should be able to use the distance formula, the midpoint formula, and then do some simple work with circles.